Hi, this is Larry Mead. I'm a principal programmer with Microsoft and Azure Global Engineering. We also have Bob Ellsworth. He's the Director of Mainframe Transformation with Azure and Application Infrastructure Solutions. And he and I are going to be doing a presentation on what it's like to take a mainframe and transform some of the applications that it's running into Azure. With that, I'll give you a brief introduction of things that you might want to consider if you're looking at potentially moving off a mainframe into Azure, things to take into account. Then I'm going to turn it over to Bob to talk about the platforms we cover and the transformation goals and options that we have with going to Azure. Then I will talk about the transformation details of actually doing some of this things as you're moving into Azure. And then finally, Bob will give a summary. And with that, I'm going to turn it over to Bob to do an introduction.
Okay, well, thank you so much, Larry, and thanks for the opportunity. And it's sort of interesting, the picture Larry just showed looks like an old 360 Mod 30 from the 1969-1970 timeframe, one of the platforms I worked on. And so my background, for those of you I haven't chatted with previously, 30 years on mainframe, starting back in 1971, and then 20 years here at Microsoft. So it's been great being part of this digital transformation and helping customers move to take advantage of the latest technologies, especially during the last few years as customers move these workloads up to Azure. And back to you, Larry.
Sure, a little bit more detail on who I am. Again, I'm Larry Mead. I'm with the Azure Global Engineering in a group we call Mission Critical Systems. And I don't quite have as long on mainframes as Bob. I only spent about 17 plus years on mainframes before moving over into more the Microsoft world. And I've been with Microsoft now for over 26 years. And I'm a little bit more of an applications person. Bob's a little bit more of a systems person. So we'll bring both of those views towards what you might want to look at as you're moving into Azure. And I've always been someone who's worked on systems that have large transaction volumes and need high availability. And sometimes people, wonder how you're going to get that with cloud systems, and that is something that we will talk about as we go through the presentation. With that, I'm going to cover just a few things that I think are important if you want to take something that you're running on a mainframe, which is a mission-critical platform, and then put it into a cloud system. And this would be any cloud system, but specifically I'm going to be talking about Azure. First, you want to have availability, because one of the things that you worry about whenever you move something off premises is, is this in my region? Do I have sort of data governance rules I have to follow so it's in my region? And also, the second big thing you worry about is what's the latency I'm going to introduce if I do something like this? So having data centers throughout regions also reduces latency as we're going through it. Then finally, one of the leading things that we worry about is the network and having the high availability that we need that's supported by that type of a network. So Azure does have all these things, and we're constantly adding new regions into Azure. So therefore, we've got a group that's what they do, is they go out and global expansion, it's called, and then we will continue to add more in other regions, as well as upgrade our regions in the United States moving forward. So this is just a slide that shows the kinds of things that we do in order to have the most comprehensive compliance coverage that we can possibly do. And we're all the time working on this. And the reason for this is these are mission critical applications. So if you're going to move it into the cloud, you want to make sure that you have all the various types of systems that, and certifications that you're needed in order to run those types of systems. And we take that very seriously at Microsoft and work very hard with Azure in order to make those things happen. Then the last one that I have around here is sort of the attributes of what your cloud infrastructure needs. So we want to have a data center availability and high availability with the design, but we also want to have commercially available systems as well as government available systems. In other words, it's not the same thing to run a commercial system as it is a government. There's different rules that we have to play by. So we do have unique government opportunities. We have a team called Hybrid, I should say Sovereign Cloud within Microsoft Azure that looks at how to have those types of systems supported within the various regions. We also want to make sure that most times when you move a mission critical application into a mainframe, if it's a large mainframe, that it's not an all or nothing kind of a system. In other words, you don't flip a light switch and all of a sudden it magically is in the cloud. So we work very much with what we call hybrid cloud connectivity, such that we can do these things and then be able to not disrupt business as we're moving into the cloud. Some of the other things we look at is, again, this high availability, but we also want geographic redundancy. Maybe something that you don't even have with mainframes today. You can add that in moving into the cloud system with Azure. The other things that we would have is that network. I already mentioned that. Then some of the things that you might want to do with the cloud aren't necessarily just run the same old mainframe application. You want to take advantage of new form factors and capabilities that you have within the cloud. And we'll talk about ways you can do that. And then finally, it's being able to have that security that you need to be able to look at who's trying to access your system and what kind of intrusion might be detected and how to mitigate that. And with that, I'm going to turn it over to Bob.
Great, thanks, Larry. And so when we think of the platforms that we cover, we think of mainframe as IBM Z-Series and Unisys ClearPath. Of course, that combination of Sperry and Univac back in the 1980s. We also think of Midrange and Enterprise Unix as really being a different class of servers, delivering not quite as high capability or scalability, but definitely mission critical for many, many customers. And so the IBM Power Systems, we actively engage on both System I and System P, on the Unix systems, both from Sun, Fujitsu, and HP. And so there's the beauty is that no matter what type of system you have for running those mission critical, business critical applications, mainframe and midrange, we've got paths to help you move those systems to take advantage of the latest technology. As Larry will click on the build, we think of those paths which will cover both rehosting, refactoring, and re-architecting. And so these are methods that we've used working with our customers over the last 14 years. The next slide. And we think of the transformation goals. We always start with, what are the business challenges and the business drivers? Because that really helps to dictate or determine what is the best path forward in doing a modernization or a transformation of a workload. The number one historical goal or strategy, business drivers our customers have had, is cost. Mainframes it's an incredible platform. IBM does an amazing job on the IBM Z-Series and on the mid-range power systems, but it's also very, very expensive. So those costs continue to include both hardware and software from IBM and third parties. And those costs continue to increase. More and more, and I think it's definitely being increased. The awareness of it, the skill shortage, has been increased by the impact we've seen from COVID. And more difficult to find programmers to maintain the applications, and even more so systems programmers to maintain the operating system. So skill shortage tends to be a challenge a lot of customers like those attending will probably experience. Flexibility and choice, the desire to embrace other architectures and workloads, to embrace the cloud, more difficult to do for those mainframe workloads. And then agility. Just that ability to update applications and systems to be responsive to the market, more difficult to do using a waterfall process in development, much easier in modern development to use a DevOps process to run incremental changes. And so these business drivers as challenges, that will really help dictate what is the best path forward for a mainframe modernization, mainframe migration. And next slide. So a lot of times, customers will wonder, well, gee, Microsoft, mainframe, what the heck do they have in common? Well, it just so happens we actually started our Mainframe Migration Alliance back in 2004, and then built out a mainframe migration team and offering an engagement process starting in 2008. And so for the last 13 years, we've had a big focus on ensuring that we build out a partner ecosystem and that we, through our experiences on helping drive more than 1,000 mainframe migrations, that we can help guide our customers to make the right choice to be successful in their mainframe transformation journey. So it's that ecosystem of partners and that long experiences and dedicated systems that we have across Microsoft that allows us to become trusted advisors with our customers. Next slide. And we think of these paths to modernization, and the presenters from both AWS and GCP did a good job representing this as well. We do go back to the standard Rs, remote hosting being the first path, where outsourcers such as DXC or Kyndryl, Atos and Sono provide for hosting of mainframes with high-speed connections to the cloud. So that way you can surround the mainframe with x86 systems running in the cloud and provide for running those mainframes as is in these hosted environments. Always customers are retaining the applications that they have and surrounding that mainframe, retiring applications you no longer need. As far as retaining, opening up web services for services-oriented architecture, being able to replicate data for BI or analytics. You're always replacing custom apps with packaged apps if the packaged app delivers the value you need. And the area that we focus on the most is replatforming, rehosting, refactoring. So replatforming, keeping COBOL as COBOL, replatforming, moving the instruction set from load modules on the Z series to runtimes in x86. Rehosting, keeping COBOL as COBOL, but running it on Windows or Linux. And refactoring, converting from COBOL, PL1, assembler to Java or C#. One of the questions asked earlier during the other presentations was, what percent do you see each one of these handle? Typically, rehosting, we see about 70% of our engagements where rehosting is the option that's chosen, about 20% where refactoring to Java or C# is chosen, and about 10% where rewriting the applications is the best path. Again, it really depends on the customer desires and their business needs and their business challenges. And then re-envisioning, rewriting, re-architecting, again, 10% of the engagements that we have is the path that's chosen to keep evolving these workloads on lower cost platform. And next slide. So back to you, Larry.
Okay, so I'm going to talk a little bit about transformation details, and I'm going to look at some of the things that why you'd want to use Azure for this type of a transformation. So if you're looking at mission critical systems, you want to have the capability of having this high availability. Well, we've already talked a little bit about the fact that we can set up within a region, we can have multiple availability zones so that you can have high availability within a region, and we have the technologies that will allow that type of failover. But you can also take and run that across geographies. So we have geographic pairing, if you will, that can take place within the region such that you now could actually fail over to another region if you had some kind of a disaster within the region that you're working with. And one of the other things that we look at is the ability to both scale out and scale up. Typically, you've got the cloud system will want to scale out is its normal kind of capability, but some of the mainframe applications, without doing a large re-architecture, do need scale-up capabilities. That means you have to have very large VMs that are available, and you have to have the network and storage systems available to support those. So that's all available in Azure too. So it's not really one size that fits all, and sometimes it's mix and match. If it's a large customer, you're going to have both. Some that you want to scale out and perhaps you want to refactor or rewrite. Others that you want to scale up and keep things pretty much the way they are as you're moving into the cloud. The other thing that we quite often run into is questions around, well, I've got this really high volume of transactions that are taking place. That could be payment systems, it could be like claims and healthcare systems, et cetera. So how am I going to do that? And we can do that again with scaling up, but you could also maybe look at other capabilities, which if you take platform as a service, you might be able to take that and have sort of clusters of compute that you can then use as needed, which allows you to only use for the compute as you need it. And so this allows you, when you have things like data center closures, to find a way of being able to find a place to put that in the cloud without worrying about whether or not we can handle that type of volume. Another big advantage of moving into cloud systems is access to other types of systems. We've had a number of customers, once they get the data in the cloud, it opens them up to analytics that they can run, and machine learning and artificial intelligence and things of that kind. I've already briefly talked about on-demand bursting, but this is something that one can save a lot of money because it's the way IBM will typically charge for and other vendors too. The software that's running on the mainframe, it's based on the highest four-hour period that you have for the month. And if you've got on-demand bursting within a cloud platform like Azure, you could have that done, and you can then bring back down to what your steady state is, which is maybe 1/10 of what that bursted state is, for much lower costs. And then one of the first things that we see people go to, even if they're not going to move the application itself, is move their development and test, their DevOps, if you will, into a cloud system, because that way you can take advantage of capabilities that the cloud is offering you for actually doing maintenance on your system without actually moving it. And by this, I mean you could do it in PL1 or COBOL. There are tools that allow you to do that and work with modern DevOps that are cloud-based. So this is going back to what we say is we need to look for the right path for the system. Do you need to rehost because you need to get to the cloud quickly? Are you facing a data center closure, for instance? Do you want to refactor because you want to bring in new resources to use this in Java, but keeping the application more or less intact from a point of view of the architecture? Then finally, we've had quite a few customers, at least that I've worked with, who say, you know what, the last thing I need to do is move what I currently have into the cloud because it's not meeting my business need. I need to find a way to then bring that over into the cloud and then make it worth my while to undertake that type of project. Then finally, this hybrid approach is one of the best ways to minimize risk. And Microsoft's always been about interacting with the mainframe, and we've brought that mentality into our cloud systems too. So again, some of the sample scenarios are these high volume transaction systems. It's also rehosting proven core systems. Do you really want to change something, or do you just need to get it moved into a lower cost environment? And the last one that I have here is this cloud native type approach. Sometimes you want to do that because what you're doing on the mainframe doesn't really give you what you want. For instance, I'm working with some customers who are, say, taking something like Spark Compute and using our version of it that runs with Databricks in Azure as a PaaS service to then be able to apply lots of compute to then get a workload that's done very quickly rather than having it done the way it was traditionally done with batches in the mainframe. What that does is that takes that time window that you might have at the end of the day, and it makes it such that you're more likely to meet it, because that's always a problem with these systems, is what happens if I have to restart or something of this nature? What can I do? And the more you can spread out the compute, the more likely you are to be able to have more breathing room in getting that done. So one of the things that we're often asked is, okay, if I'm interested in doing this, how do I sort of take this and say, you know what, how do I map my compute that's on mainframe into a compute that's in Azure on the cloud? And so a study was done with HP at the time and Micro Focus and Microsoft to then say, okay, what is the typical number of instructions per second? Mainframes are typically measured in MIPS, millions of instructions per second. How does that match with a mainframe processor into cores that are running in Azure? And what we found is that at least with the workload that we tried, which is sort of like a TPCE type workload, which had both batch and online, that the batch, you could get about 170 MIPS per core on a on a modern Intel-based processor. And then with something that's more of an online, using something like CICS, you could get even more MIPS. You could get 288. So we use these as guidelines, and we like to be conservative to make sure that we've got plenty. We typically say, oh, why don't we just say 150 MIPS per core? What that means is you can get up to well over 400 cores on some of our VMs within Azure. Well, that means I've got a lot of MIPS. I've got approximately 30,000 MIPS that I can get just on a single VM if I want to, and that doesn't even include if I was to be using some type of compute cluster, which even throws more compute at it. So people often ask, do you have the power in the cloud? And the answer is definitely yes. It's just how do you want to apply that? So I've got a couple of architectures here that are actually shown in this single Visio that we have here. One of them is taking and doing what is more or less a rehost. It's where I'm taking and I'm moving, it's sometimes called lift and shift, where I'm taking the COBOL code and I'm just recompiling it and running it under an emulation for IMS or CICS to then deploy it on a cloud-based system. I could be deploying it on multiple VMs, or actually most of our partners, including TMACSoft, who's going to be talking later, you could also deploy them in containers and then run them in that way if you're so interested. But another way this can be done is if I want to refactor it and I want to say move it into Java, which is what this left side stack shows, I could then host it in like a Kubernetes cluster. And that Kubernetes cluster could then have multiple pods that are running multiple nodes, and then you could then turn and deploy that and have almost unlimited compute, which could then be managed in multiple regions. We'll talk about a little bit more about that as we go along. But as also remembered, you might remember, is we had these other kinds of systems you might want to add to it. For instance, stream analytics, you might want to add in the Spark compute, or you might want to then store the data in things that are not what you would typically run in the mainframe. So there's a lot of different capabilities that are bringing to bear here. This next one is showing if you were to take something like a Sun Spark system and move it over into Azure. So we not only work on mainframes, IBM mainframes and Unisys mainframes, but we also can have approaches. For instance, if you have something like legacy Unix, especially things like Spark or HPUX or something of that nature. With that, I'm going to turn it back over to Bob to talk about some customer examples.
Yeah, thank you, Larry. So let me touch on just a few of those. Just one comment first on the benchmark you showed previously. That very same benchmark was done both by Cisco and LZ Labs and found on a 128 core virtual machine up in Azure, they could do 20 to 25,000 MIPS on a single virtual machine. So it's been reproven in the latest technologies. And as far as customer examples, and you'll have these in your deck, so the deck that we'll share, so you can look at these in the future. Just a few examples of customers that have taken this journey of moving these workloads to the cloud. First one is Jefferson County, Alabama. So a pretty small Unisys mainframe, but big challenge that they had with skill shortage and wanting to move to a modern DevOps environment. They decided to recompile the COBOL using Micro Focus. Our partner Stadia did the migration and deployed the system up in Azure with significant savings for the customer. So a project that was done ahead of time and on budget, but also giving the county significant savings and addressing the skill shortage issue that they had. And next slide. And even a larger one that was just fascinating was the U.S. Air Force Material Command. And U.S. Air Force, their whole goal is to increase the uptime of aircraft. And this system was used to monitor maintenance on the aircraft. But the thing was they needed to unlock the system and get it into a more modern environment so they could use AI, machine learning, BI to do predictive maintenance. So the first step was to migrate this workload from the Unisys mainframe up into Azure. They were able to save about 75% of their cost by getting off this Unisys mainframe and utilizing the Azure services and capabilities instead. So again, this one used microfocus technologies for the COBOL compiler, and it did allow them to move from their mainframe database, UDS, up to SQL Server. So they're now able to start taking advantage of new technologies, cloud-based technologies, to improve the airtime uptake or the maintenance on the aircraft, improve the airworthiness and the uptime of the aircraft as well. And next slide. A good example of a rewrite would be with Geico, another public case study. In Geico, they had a challenge where they had 3 separate policy management systems, wanted a single policy management system. So they started on the process to rewrite their applications on the mainframe using Visual Studio and retrain their programmers to use that developer environment. As they started the rewrite process, they started with some of the smaller applications first, fraud detection, auto new business, and they were able to get those deployed initially on-premise on x86, Windows, and SQL, and then move them to run up in production in Azure. They've now completed the rewrite of the vast majority of their applications, and they're using Duck Creek from Accenture for the policy management system. So a good combination of rewrite, but also using packaged cloud-based apps for these solutions. Next slide. Yeah, again, very mission-critical credit card processing organization, wanted to expand to other countries and offer the credit card processing services. They didn't want to have to deploy a mainframe in each one of those countries to support it, so instead rehosted their core processing systems using Microfocus and Wipro. And this way they could then offer these to other countries and expand their business. So very successful in supporting their business needs. The next slide. And this one's a fascinating one that both Larry and I worked on. This is a credit card transaction inquiry service, pretty big mainframe, more than 50,000 MIPS. They had 100 terabytes of vSAM. Consumers would go online, look at their credit card transactions or the credit card statements using the service. For them, they'd already rewritten the COBOL Kix applications, which were pretty small, had rewritten them in Java. But the challenge was how to find a database in the cloud that would deliver the performance they had with vSAM in a Kixplex on the mainframe. Larry and the team worked with them to reprovision this to use Cosmos DB and geographically disperse that across 3 Azure regions. The performance test that was done 6 months after we started this process, or less than 6 months, showed that we could deliver higher performance and scalability at a significantly lower cost by using Cosmos DB in Azure. The system went production in December, and they've been extremely happy about just the cost savings and also the increase in performance and responsiveness. And next slide. And then this is an extremely large customer, privately held capital markets organization here in the US. As we engaged with them, their goal was to eliminate the mainframe from the data center in the next 5 years. We've already worked with our partners to rewrite the first set of applications. The second set, which is the record-keeping system, is being rewritten at this point to be able to use the cloud to do that reconciliation after the market closes. And we hope that that goes production the first part of next year. So very successful utilizing cloud services and starting to drain down the capacity utilization or requirements on the mainframe. And next slide. So a few customer examples for you, but good examples of customers that have already gone production running their mission-critical workloads in Azure. And just to close this off, I know we're at the end of the time, to leave you with a couple things. First, the Microsoft and the Azure mainframe migration. As I mentioned, we've got extensive experience in helping customers over the last 13 years on this journey. We've got an extended team across the company, both myself and the Azure Apps and Infrastructure, Larry with the Azure Global Engineering team, but also an extensive set of resources in Azure Data R&D. As Larry mentioned, our Azure Cloud Engineering services, where we do have a mainframe here at Microsoft used for testing interoperability using our technology host integration services. And then the technologies. When you think of a mainframe, you're expected to get reliability, availability, serviceability. Well, properly architected in setting up and using the Azure services available, you can provide and achieve the same level of RAS that you've come to expect on the mainframe. So the capability is there, but the ability to go beyond that, as Larry mentioned, with Power BI and data and analytics, new ways of developing applications, new ways of deploying them with containers. Those are all the opportunity you have to take a legacy system and continue transforming it using the latest technologies. And next slide. And very similar to the good presentations from AWS and GCP earlier in the day, we've got a very mature partner ecosystem. These are the top partners that we engage with, both global systems integrators, hosters or MSPs, regional and local partners, advisories, and the ISV partners. So as you're probably hearing from these presentations, this is a very small community. We all work very closely with our partners to ensure that you can be successful in choosing the right solution to be able to move forward and move these workloads off the mainframe and take advantage of cloud services. Unfortunately, a couple sessions from now, TMACsoft will present their solutions and the rehosting capabilities, and they're one of the very good partners for us. And then lastly, to leave with you a set of references and links to videos and webcasts and blogs to give you an idea of some of the other experiences we're having with our partners, and give you some more information that you can consume as you're considering a journey to migrate workloads off the mainframe. Okay, so back to you, Ron.